So this is ArcGIS GeoAnalytics Server, an introduction. If you realize you're in the wrong room, feel free to leave. But we're going to begin. I'm Sarah Ambrose, and this is Ravi to my right on the ArcGIS Enterprise team. So what we're going to actually be looking at today, I'm going to give you an introduction to the GeoAnalytics Server. I'm going to go through some analysis I'm actually going to demo what we can do with GeoAnalytics first. So I'm going to do 3 demos through different user experiences to show you what you can do. I'm going to go through some analysis concepts. And then we're going to look at GeoAnalytics data sources as well as some server administration. So how do you actually set up GeoAnalytics Server? How many people here are actually familiar with GeoAnalytics Server? Has anyone ever heard of it before? Okay, we have people who have heard of it but have not used it. So what is GeoAnalytics Server, in case you haven't heard about it? It's a new way of processing large vector and tabular data. So this isn't for raster data, it's for points, lines, polygons, and tabular data. And usually this data is going to have a spatial component as well as a temporal component. You don't need to have either of those. You could have tabular data with time, you could have spatial data with time, you could have just temporal data. You don't need temporal data though, so don't assume you need to have spatiotemporal to actually use GeoAnalytics. And this GeoAnalytics server is actually designed to be distributed across multiple machines. So you can set up multiple machines to analyze your data, and it's going to distribute the analysis across multiple cores across those multiple machines. So this makes your analysis much faster. So previously you may have tried to run something on ArcGIS Pro, and analysis was just too difficult to complete because you had so much data. Here we're actually able to take advantage of multiple machines to distribute the analysis and actually get answers, and faster too. This could be something you could previously answer in desktop, but maybe it took a few months or a few weeks, and now we're hoping to get it down to minutes or hours, depending on the analysis and the number of machines you use. So for the actual questions you can answer, a few examples are something like, using millions of emergency calls accumulated over the last decade, which areas had the highest rates of emergency calls? What are the most popular taxi pickup locations in New York City, and how is this trend changing weekly? And my last example is, what is the flight path of recorded GPS tracks, and how many of those paths occurred within 100 kilometers of a no-fly zone? So GeoAnalytics Server extends current ArcGIS analysis capabilities. So you're probably familiar with running analysis in ArcMap or ArcGIS Pro. And we're really using we're continuing to use those powerful analytics that you know and love. What we're doing, though, is adding the distributed analytics and distributed storage. So all of these tools available in GeoAnalytics, we've rewritten the algorithms to distribute them for you. This is all integrated into the ArcGIS platform. So we're using that rich geoinformation model that's already available to you. So all of the results of GeoAnalytics, they don't have to go to some crazy big data framework. They're just going to create a feature service that's available in your portal, which you can then use however you want to use it. So a feature service can be used in Portal for something like sharing, creating smart mapping, but you can also use that feature service in Pro and continue your analysis in Pro. Oh, I didn't show you that little picture, but there it is. So as I said, you can continue your analysis in Pro, but GeoAnalytics is available out of the box. So there's no custom writing your own distributed tools so that you can actually implement these algorithms. We've done it for you, and it's available there in Pro, so it's going to look like a normal geoprocessing tool. The same thing with Portal. You're going to see your tools in Portal, but when they actually run the algorithms, it's happening on your GeoAnalytics server. As I mentioned before, you're now able to run analysis that took too long before or was too big for a single desktop. So maybe it took months, and now we can get it down to weeks or days. Or maybe it was something that took hours or days, and now we can have it in minutes. In some case, a few seconds as well. So I mentioned the Pro user experience. You'll see that we have GeoAnalytics tools available in ArcGIS Pro. And then we also have them available in the Portal web map viewer. So these tools, again, to reiterate, you can see them there, you fill out the tools, you run them, but they don't actually run the analysis in that interface. You're not running it on your Portal machine or running it on your ArcGIS Pro machine. The analysis happens on your GeoAnalytics server that you've set up, so you can have as many nodes as you want. So you could have 1 machine, you could have 10 machines that are actually running this analysis. You can also use this as a developer. So because this is integrated with Server, you can use the REST API to automate your tools, as well as the new ArcGIS API for Python. So if you're using the ArcGIS API for Python, you'll know this is a portal-centric Python development. You can use Jupyter notebooks like this image here, and I'll show you an example later. But the geoanalytics tools are available there. So if you wanted to go run something like Aggregate Points, and I'll explain what that is later, you could just go into your Jupyter notebook, run that tool, and you could add it to a map right there. So what kind of data are we actually talking about when we're looking at GeoAnalytics Server? So this is an example of New York City taxi pickup locations. So this is 170 million points accumulated over 1 year. We actually have multiple years of this data, and you can go find it right now and go try it out and see what you can do on desktop. But you might find that you want something that actually distributes the analysis and run this through GeoAnalytics Server. So these are the taxi pickups. And the first thing we always do with GeoAnalytics, and that I always recommend, is really to aggregate or summarize your data in a way that it makes it much more meaningful. So here we can see that we have a lot of taxi pickups, but we don't have much information about it. So we could use something like census boundaries to actually aggregate the data into. So again, right here, we've aggregated that point data into polygons, and we're able to see a lot more information. Where are the most taxi pickups? Where previously, with that point data, we weren't able to understand much. Here's another example with flight-aware data. So these are flights across the globe, as you can see. Can you see it now? Yes. Here it is here. You can see it here. And then we can actually reconstruct tracks. So GeoEvent is something that you can use for ingesting your data. And a lot of users are ingesting their data now, and they have a spatial and temporal component, which accumulates to a lot of big data. So with GeoAnalytics Server, we can analyze that data. And so here, this would be something that someone could ingest with GeoEvent. Then we could actually turn it into something more meaningful where we have tracks like this. So you can actually see where these planes have gone. So I'm going to switch over to a demo now in Pro first. And I know you can't see anything yet. So here I have momentary outage data, and you can see it. Good. This is just a sample. So I actually have 54 million points, and you're just seeing 200,000 at this point. This is from CenterPoint Energy in Houston, and it's momentary and continued outages. And what they do is they accumulate their data in CSVs. So they actually have over 250 CSVs for 18 months, and that's what I have right now. So I've just opened up one CSV to show you a sample. Again, with GeoAnalytics, I don't say, go draw your data. This is just for demo purposes. The first thing we really want to do is aggregate that data. So I've already run this, and you can see my geoprocessing history here. I was up late last night, 8:32, not that late, but I ran Aggregate Points then. So this is a tool that I always recommend people start with. If you have point data, we want to aggregate points. So I browsed to a layer. Here's my electrical outage data. So right now I browse to a big data file share, which is a new concept for GeoAnalytics, and it's a way of attaching your data to your GeoAnalytics server so you can actually analyze it. So in this case, I browse to a location that's holding those 250 CSV files. So when I run the analysis, all 250 CSV files are going to be analyzed. You don't need to go put them into a single CSV file or a massive shape file and try and run that. We can use all of those files together at the same time. So I create an output name, and this is going to create a feature service because we are very portal-centric. And then I can create a bin or a polygon. So I showed that New York City taxi example where I aggregated into polygons, but we realized that not everyone has a polygon data set they actually want to aggregate into. Sometimes you just want to aggregate into something that's a bit more raster-like. So that's why we have the bin option here. And we can choose between square or hexagons. So I went with 2-kilometer hexagon bins. You can do something called time stepping, which I'll go over in a second. And you can also create summary fields. So if I didn't select any summary fields, I would just see the count of points. But I can also do summary statistics on different fields that I have available and do the usual summary statistics such as count, mean, sum, min, max. I won't read them all, but they are there. And then I can run it. So what I get is something like this. So already we see a lot more information. What's interesting is this is just the count, but I calculated those summary statistics, and if I go and symbolize on those different fields that I've calculated, I can start to see different patterns. So here already, before when I did count, it was pretty similar to the population density of Houston, but here we see that we probably have a problem right over here, where we're seeing a much higher mean outage minutes. I'm going to talk a bit about time stepping now. So this is a tool I also ran. It's the same Aggregate Points tool, but because this data was temporal, sometimes you want to see how your data changes over time. So I browsed to that exact same layer, same binning. I did a slightly larger bin just because I wanted to try something new out. So remember, this is just exploring your data at this point. And then I set a time step interval. So I set the time step interval to 1 month, which means I'm going to get a feature service that has a start and end time for all of the features, and it's going to step by 1 month. So what that actually looks like when I run it and enable time stepping is that I'm going to see how it actually changes. So as I step, I can see the changes in my data. So with GeoAnalytics, spatiotemporal analysis is built in. So we know that spatial is always built in with ArcGIS, but temporal is a huge component of big data. So a lot of the tools have something that makes it temporally enabled as well. So with GeoAnalytics, a lot of times people think, I'm just going to run my GeoAnalytics tools. I've done GeoAnalytics, great. But what actually you want to do is integrate with that with all your tools in Pro as well. You're not just done because you've aggregated points. You're going to start asking questions. So something we wanted to see was, is something changing over time, but are there any emerging hot or cold spots? So I created a quick model. I ran create space time cubes. This is something that's available in desktop right now, but it's also available in GeoAnalytics so you can handle bigger data. So I ran create space time cube, and then I ran emerging hotspots. And this is a tool only available in Pro, and I think ArcMap right now, but it's not available in GeoAnalytics. So when I ran this, oops, that's the scene. I got my emerging hotspots here. I'm not going to go into the details of this tool. There's some really great sessions on this that Lauren, Flora, and Janora give. So I would really recommend checking out the spatial analytics team's presentations if you are more interested in Create Space Time Cube. But you can see here that I'm able to see different trends that are appearing. So something like this here is a persistent cold spot. So that means that we're not seeing a lot of outages there. So this is probably an ideal location to look at and say, this is something that we should be doing everywhere. So maybe we have a different team working there and they're doing really well, or maybe there's something different from other areas that we could look into. Usually red means something not so great, so I'm going to look over here. Oops, don't hit your time slider. And I see that I have an oscillating cold spot. So as an oscillating cold spot, we could look into see what's happening. Why is it oscillating? We could look at our time series data. Maybe it's seasonal. So this is information that we can now look into as opposed to what we saw from that point data originally. The last thing I want to show, and I can't take too much credit for it because it's not my team, is the Space-Time Cube Explorer. So we created a Space-Time Cube with this model here. But there's a really great way you can now explore it. You just do a simple add-in, and you're actually able to visualize what your data looks like over time. So it's these same locations, but then we have time on the z-axis. And because I did emerging hotspots, you can see those same patterns to see what is significantly hot or cold. So I mentioned, well, I want to say that I see a lot more information here than I originally saw with all of those points. But I've also mentioned that you can do these similar tools in Portal. Has anyone ever run a tool in the Portal web map or ArcGIS Online? Yes, I see one yes. Okay. So in Portal right now, at 10.4.1, you're able to run standard tools. But you're also able to run GeoAnalytics tools if you have a GeoAnalytics server. So this is your Portal web map, which is very similar to ArcGIS Online. I should emphasize GeoAnalytics is only available with your Portal. It's not available in ArcGIS Online. So if I hit analysis, I'm able to actually browse to my geoanalytics tools. So what I've actually have here is hurricane data. This isn't a huge data set, but I really wanted to show what you can do with geoanalytics. So this is a hurricane data set. You can see that it's time enabled, and it's just raw points. They're GPS measurements. They have the wind speed, wind pressure, a bunch of attributes that I can look at. What I've done is I've gone to analysis, and you can see that I have those same groupings. Actually, I don't think I showed you in Pro. You can browse to your tools here. So you have analysis, and you now have portal analysis tools available here. When you select this, you can see your geoanalytics tools, and we've divided those tools into different tool sets to help you guide what you actually want to run. So I always like to start with summarizing data. As I mentioned, there's aggregate points, but the tool we're going to be running is called reconstruct tracks. So that's similar to that FlightAware demo or image I showed earlier, where you're taking points and turning them into lines. So for hurricanes, this makes sense to do. We're going to take points and we're going to turn them into lines to see where these hurricanes actually traveled. So I ran the reconstruct tracks tool. Here's my hurricane data. I just need to select an identifier for the tracks, so the serial number in this case, but that could be a hurricane name so it knows which points to join together. A geodesic or planar method. Usually we recommend geodesic, but if you're in a local projection we all know that it's hard to remember if it's small scale or large scale, but if you're really zoomed in to a projection, planar is probably okay, but geodesic in most cases. And then you can optionally buffer it. So I'm going to show an example of one buffered and one not buffered. Not buffered, you're just going to end up with a line data set. If you buffer it, you're going to end up with polygons, and it's going to buffer each point and then create the convex hull. And so there's a simple expression builder that you can use to actually create your buffer. So you can use a bunch of different field attributes to create your buffer. What I did for mine was I did wind speed times 100, just so that we could actually see it. So when we look at those results that I've created, this is what the line data looks like. And we can see as we step through time that these hurricanes change. We also start to see that we have more hurricanes over here, but I think it's just because we didn't actually receive any data before that time. It's not suddenly I've proven everything, that the Earth is changing drastically around 1968. And then we can also see it with polygons. So what that looks like, if you zoom in, you start to see the hurricanes are wider where they had a higher wind speed. So this isn't cool visually, but also we can start looking for patterns here. I have one more demo I want to show, and that's with the ArcGIS API for Python. So I have my Jupyter notebook here. Let's hope my internet connection is working. And I'm going to hit run. So the first thing I'm doing is I'm just importing the Python modules that I need. I originally thought I had a CSV, but I watched the plenary 2 days ago, and I saw them magically enter their password. So I don't need this anymore, or this line anymore. Ooh, what is it? Let's see if that's it. Looks good. All right, so I've connected to my GIS, so it now knows which portal we're working with. I want to verify that GeoAnalytics is supported. So true. And I'm now going to search for a big data file share. So I have a bunch of items in my portal. I've already created a big data file share, and I know that it's called something like Drew's demo data, so I'm going to search for that. And then within a big data file share, you can have multiple data sets. So I'm going to search for the layer called outages in my big data file share, and that's what I'm going to save as my data layer to use. So it says, using the following data set, electrical outages. So this is the same data that I was using in Pro. And I can now run hotspots on this layer. So if you look at the API documentation, you'll see that all of the geoanalytics tools are available in the ArcGIS Python API. So they're under those modules, those same things that are the tool sets in Pro and Portal. And you can see that I'm actually going to be running this tool here, find hotspots. So I'm going to hit run on that, but I think it might take a few minutes, so I'm going to switch back from my demo to the slides.
Is your data set in the background geospatial?
This data set, so this is the same CSV data set. It has X and Y columns that I've actually registered to say these are the latitude and longitude values. All right, so I mentioned a few times that we're running the tools through Pro and Portal or the Python API, and the analysis is happening behind the scenes. So what's really happening, this is a simple architecture of what you're seeing when you run analysis, is you run GeoAnalytics and it's grabbing the data from whatever source you're using. So it could be a feature service, it could be a big data file share, and it could be data coming from the ArcGIS data store, which is usually a hosted feature service. The analysis is run on the GeoAnalytics server, and when the results are run, they're written automatically to the ArcGIS data store. So this is exposed as a feature service, which creates a new layer in your WebGIS. So all you've seen is you've run a tool and you have a layer returned, just like any other tool that you would run anywhere else in the ArcGIS platform. Of course, that exposes the layers, and then you can use them through Pro, like I did. I used a model builder to continue using my layers. You could use them in Portal, so if you wanted to run those GeoAnalytics tools, and then you could do whatever else you wanted to do in Portal, such as using smart mapping, which my results actually were using smart mapping. That's why they were much prettier than I would ever design by myself. You could use them in the ArcGIS API for Python and the REST API. You don't need to isolate them to one or the other. I could go open those Portal created layers in Pro, vice versa, move them all around. I'm going to do a quick analysis overview now of what we actually have in GeoAnalytics. So most of these tools are patterned after the ArcGIS Online spatial analysis capabilities. So these were tools that became available in ArcGIS Online a few years ago, and we chose those tools by looking at what are the most common workflows users use. So people have been using ArcMap for years. What are they doing most often? So something like aggregating points or summarizing within. They were these tools that you probably chained a few things together, but logically they were the actions you were doing most often. So those were available in ArcGIS Online and then Portal, and we looked at those tools and said, what makes sense for big data? Not all of them made sense, but a lot of them really did. So a lot of the aggregation and summarizing are what we used. We emphasized those tools, but we also tried to add a temporal component when it made sense. So for time, I know with geometry you're probably familiar, point, line, polygon. With time, we have two concepts of time, instant and interval. So an instant is just a single moment in time. So that would be something like those hurricane GPS measurements. There was a single point with a single instant in time. When I reconstructed the tracks, what actually happened was I created a track which was the line or polygon, but it was now an interval. So it had a start time and end time based on the first and last point in the track. For the actual tools we have available, so these are those 5 tool sets that we have. Summarize data, of course, being the favorite one I'm pushing today. And we have 5 tools there. So we have aggregate points. So that's where we're aggregating points into bins or polygons. And we could add time stepping as well. Join features. I think this is probably the most powerful tool. Aggregate points is conceptually a subset of this. So join features, you could join points, lines, polygons to points, lines, or polygons. But you can also do something like a temporal relationship. So this instant happened within 1 hour of this other instant, or this instant happened within this interval. Reconstruct tracks, I showed that one. So reconstructing points into lines. Summarizing attributes. This is your summary statistics, so it's creating a tabular output. There's no spatial output here, but you can use spatial data as the input. And summarize within. This is similar to aggregate points, except you can summarize points, lines, or polygons within polygons. And you can calculate the proportional lines or polygons area within those polygons. Find locations. This is or find similar locations. So this is an attribute comparison. So which features are most similar to this ideal feature that I've selected? Analyzing patterns. So you can do calculate density. With calculate density, you can do a time step as well. So it's similar to calculate density that you would use in desktop, except that it's distributed and there's those time step options. Create space-time cube, which I showed quickly. But again, I would definitely recommend talking to the spatial statistics team about all those details. And find hotspots as well. For use proximity, we have create buffers. So just like I had that expression in reconstruct tracks where I said I want to buffer this by wind speed times 100, I can do that same thing in buffers. So you could do something like wind speed times 10 plus another attribute. And lastly, copy to data store. A lot of people want to start with copy to data store. They just want to copy their data to create a big feature service. I wouldn't recommend that because you're still just going to try and draw this huge data set, and you don't get much information from that. Something that we do use it for is moving data between the spatiotemporal and relational data store if you need to do that, because there are those two different data stores configured under the ArcGIS data store. And if you have questions about that after, I will definitely answer it. So aggregation, what does it look like? So aggregate into polygons. This is what we showed earlier. We have our target features. I was always so confused by target and join features when I learned about spatial joins. Target features is the one that you're going to still see later. So when we have target features and we have our join features, the final result, we see those target features, but with the attributes of the join features added. And then, of course, aggregating into time steps. So we have those target features, and our join features have time. We end up with these polygons that are stepping through time. We can do the same thing with bins. So like I said, we don't always have a polygon data set to aggregate into. So you can create square or hexagonal bins of a specified size, and we can aggregate into those, as well as doing it with time steps. So let's give an example of what this actually looks like between the three different types. So aggregation of lightning strikes. This is lightning strikes aggregated into square bins. Here we have that same information aggregated into hexagonal bins, and then of course into polygons as well. When we add time stepping, we begin to see this very cool visual where we have the lightning aggregated into square bins over time. That same thing in hexagon bins, and then the polygonal, the polygons. So I've mentioned time stepping a bit, but I haven't gone into any details. I did the 1 month example, but there's actually 3 parameters for time stepping. There's the interval, so how long is the time step? The repeat, how often you're actually going to repeat that time step, and the reference time, where you're going to align it. So for example, if I had hourly time steps, I would only need to specify one of those, and I would say the interval was 1 hour. If I wanted to look at every 12th hour for some reason, I could say the interval was 1 hour, and the repeat is 12 hours. So it's going to take 1 hour, it's going to skip those 11 hours, and look at the next hour. And if I wanted to do every Monday, I need to set a reference time to say this is where you're starting. So the interval is 1 day, the repeat is 1 week, and the reference time is some Monday. And what I mean by some Monday is that I don't set a reference time and it only goes forward. If you wanted a Monday in 1960, you can set it on a Monday today, and it's going to go forwards and backwards. We talked a bit about join features where I said it was the most powerful tool. So this is a simple example, but there's a lot of different spatial and temporal relationships you can use. So target features here are polygons with an interval in time, and the join features are points with an instant in time. So my final result is all of those points that are within the polygon spatially as well as temporally, and they're added to my polygonal result. It's not always that way. You can do this with point, line, polygons, instant, intervals. So this is the opposite example where we have point data sets as the target feature, and we're joining polygon data sets to it. And you can see that I have those point data sets as the final result on the bottom right. And they're colored, of course, by the polygon because that's the information that's been joined to it. Reconstruct tracks. Here we have 2 tracks. We have the purple and blue tracks. And you can see that the time is the z-axis. So we've reconstructed those tracks based on the color, which would be their identifier, and the time we automatically order by time. So what data can you actually use in your GeoAnalytics server? So of course, because it's part of Portal, you can use any of your GIS data that's already available in Portal. So if you have feature services, you can use that. If you upload CSVs to Portal, you can use that. If you have data as a feature class right now, we always recommend sharing it to your Portal first, because if you try and run a GeoAnalytics tool on it, it's going to have to be copied to your Portal first, and sharing it is really the best way to do that.
Say that again.
Yeah, so I'm going to say it again in case no one heard that. So we recommend using a hosted layer because we're able to read directly from the database to actually read that data. So if you have a feature class in Pro, and say you have 2 billion points in a feature class in Pro, and you want to analyze it using GeoAnalytics, it's going to have to copy that data in Pro up to the GeoAnalytics server before it can run analysis. So if you share it first as a hosted layer, we're able to directly read from that. And the copying process in Pro is not as efficient as the sharing process, because sharing's been optimized to create these feature services. So when possible, use a hosted layer. The other way you can use the data, and this is another thing you could do if you had a local data set, is a big data file share. So that's how I attach those 250 records as a single data set. So if you have a huge data set that you don't want to share, but you can put it in a folder that you register as a big data file share. So this is a way of attaching data that's local, such as CSVs or shapefiles, but also data stored in HDFS or Hive. And I unfortunately didn't add it here, but at 10.5.1 we added cloud stores as well. So if you have data at Amazon or Azure, we can add that data as well. The output for GeoAnalytics is a hosted feature service. So that's something that is stored in the data store underneath, but to you it's exposed as a feature service which you're able to use throughout the platform. And then the net CDF for Create Space-Time Cube is stored locally for now. It's not going to be a feature layer. By default, results are all stored in the Spatiotemporal data store because that's optimized for fast reading of space-time data. But you can, if you want to, store your data in relational data store. But there's a few recommendations on when to do that and when not to do that. And if you have questions about that, feel free to ask me after. To actually register a big data file share, it's a pretty easy process, and Ravi's going to go through it if we're on time. Yeah, you can just take over, actually.
Yeah. Thanks, Sarah. Switch to 4.
Yeah, you're good.
Yeah, can you guys hear me? Back?
Just yell for Matt.
So, most of you, how many of you are familiar with ArcGIS Server Manager? Have you used? So this is the ArcGIS Server Manager view of GeoAnalytics Server. It's no different from any other ArcGIS server. Here, when you go to the site and data stores, you may have used this for registering a database or a folder. So in 10.5, for GeoAnalytics Server, we added the option to register a big data file share. So you can go here, and you can see different types of file share, big data file share that Sarah talked about. So the file share itself is a folder which contains your CSV files or shape files. And then GeoAnalytics Server also supports HDFS, Hive, and in 10.5.1 Cloud Store. So for registering a file share, you simply need to give a folder location which has all your CSV or shapefile data sets. For registering HDFS, you need to give HDFS connection information. And similarly, for Hive, you need to give the connection to your Hive store. For registering a cloud store, it's a two-step process. You first register a cloud store, which could be either from your Amazon, it could be an S3 store, or a Microsoft Azure storage. So you first register a cloud store, and then you register the cloud store as a big data file share. So for example, if I choose cloud store option here, I would see an already existing cloud store that I have registered. So I can register this as a big data file share. And these cloud stores can have folders which contains, again, delimited files that you want to use for GeoAnalytics. That's just a quick overview of how you register a big data file share with Manager. Here I have a single big data file share that I have already registered. And if I edit this big data file share, I can see how many data sets that I have. Here it says there are 4 data sets in this big data file share. And then I would be able to choose one of the data sets. And then I would be able to make further edits. When we register a big data file share, GeoAnalytics Server makes a best guess estimate to understand your data set. and creates what you call as a manifest. So you may have to make further changes to the manifest generated, and you can do that via the interface in Manager here. So here what you see is a JSON representation of the manifest that gets generated for a big data file share. So this is a quick overview of registering big data file shares via Manager and how you edit that.
These are read-only views, I assume?
This is a read-only, but you can edit the information here. So for example, here, let's say you want to specify a different spatial reference for the manifest. You can say that here, something like this, and then you can save it.
But
So
the data itself is read-only.
the data is read-only. Yeah, exactly. This is just a manifest that you're editing.
But you can consistently modify your data, the original data. So if you added 20 more CSVs, you don't need to do anything with the manifest, but the next time you run the tool, it grabs all of the data that's available.
Yeah.
It's made for big data because people are constantly ingesting data. Yeah. And we can show it at the island too, because we have a bunch of big data file shares set up.
So now moving on, how many of you are like administrators who would be tasked with setting up GeoAnalytics Server? Just a few? Okay. So this might be an interesting section for you. Components required for setting up GeoAnalytics Server. Portal for ArcGIS. Portal is the web front end for the ArcGIS Enterprise. If you have worked with ArcGIS Online, you might be familiar with Portal already. And Portal also provides the backend framework that lets you create maps, apps, and share it with your organization. The other component required is ArcGIS for Server. Many of you might be already familiar with ArcGIS Server, which is the engine that supports ArcGIS Enterprise. You can create a variety of services in ArcGIS Server. And here, ArcGIS Server also provides the analytical capabilities that are required for the GeoAnalytics Server. So ArcGIS Server, you can license it based on different roles. And here we will be licensing it as a hosting server and also as a GeoAnalytics server. ArcGIS Data Store is another component, which is a ESRI-provided data storage solution for storing all the spatial data that you publish to your enterprise GIS. There are three types of ArcGIS data store that you might hear. One is the relational store. The second one is a spatiotemporal store. And the third one, which I have not listed here, is a tile cache, because that is not relevant to GeoAnalytics Server. And then ArcGIS Web Adapter is a ESRI-provided load balancer that you install on your web server. And it acts like a reverse proxy. When requests are made to your web server, it directs to the specific services as needed. So these are the components that are needed for setting up a GeoAnalytics server site. Now let's go through 3 simple steps on how you set up a GeoAnalytics server. Step 1 is for you to set up a base enterprise deployment. A base enterprise deployment consists of Portal. So you install Portal for ArcGIS. You install ArcGIS for Server, and you license that with a standard or advanced GIS server license. Then you install ArcGIS Data Store and register the relational store with your hosting server. You install web adapters for your portal and server and register with portal and server. And then finally, you federate the ArcGIS server with portal and configure that as the hosting server. Here, we saw the installation of base enterprise deployment in multiple steps. So if you want to do this manually, you can do this this way. But we also have the ArcGIS Enterprise Builder that you can use for installing all these components on a single machine. That provides an easier way to install the base enterprise deployment. And step 2 is to install and configure a spatiotemporal ArcGIS data store. So on a second machine, you install ArcGIS data store, and then you register the spatiotemporal data store with the hosting server. So one of the requirements for ArcGIS GeoAnalytics Server is for you to have a spatiotemporal store, which many of you might not have installed previously. If you are a user of GeoAven Server, you might have installed a spatiotemporal store on your site, but otherwise, it's a new requirement that is needed for the GeoAnalytics Server. And step 3 is for setting up the GeoAnalytics Server itself, where you install ArcGIS Server. This setup is no different from installing any ArcGIS Server, and you license it as the GeoAnalytics Server. And then you install the web adapter for the GeoAnalytics Server. And finally, you federate this server with Portal and configure that as your GeoAnalytics Server for the site. So now let's look at a few deployment patterns. What we saw now was a simple pattern where I had 3 machines. On machine 1, I installed the base Enterprise GIS. On machine 2, I installed a single ArcGIS spatiotemporal data store. And then on machine 3, I installed the ArcGIS GeoAnalytics Server. And the big data file share that we talked about earlier, which is the repository of your input data, that could be on a separate machine. We don't want that to be, we don't want to have the input data included on the GeoAnalytics Server machines for performance reasons. And then here is a multi-machine deployment. So depending on your analytical needs, you can easily scale out your GeoAnalytics Server. For example, here, what changed was, if I go back, sorry. If I go back, here what you see, in the ArcGIS spatiotemporal data store, we have a single spatiotemporal data store. So it changed to 3 spatiotemporal data stores. So you can easily install spatiotemporal data store on additional machines, and you can join to the site. Similarly, you can install ArcGIS Server on additional machines and add it to your GeoAnalytics Server site. Here, what I show is a 3-machine deployment, but you can scale out to as many machines as needed. So where is GeoAnalytics Server supported? So it's supported on Windows and Linux platform. It's supported on-prem, where you can install it on your own server machines. Or you could also install GeoAnalytics Server on Amazon using the CloudFormation templates, or on Azure using the Cloud Builder. System requirements for the base enterprise deployment. If you're installing all the components on a single machine, the minimum requirement is 4 cores and 16 GB of RAM. For the ArcGIS spatiotemporal data store, the minimum requirement is 16 GB of RAM. And also, this being the store for all the results that are generated from the GeoAnalytics Server, you should have a sufficient disk space. And when you are using any feature services, that are coming from the spatiotemporal store, it acts like the input data source. So you should also have a fast disk for read and write. And for the GeoAnalytics Server, minimum of 4 cores and 16 GB of RAM on each machine. And when you run any GeoAnalytics task, it uses the temp space on the machine to write during the computation. So you should have sufficient temp space on each machine. So what we saw was the minimum requirement, but what we recommend is this. For the base enterprise deployment, minimum of 4 cores and 32 GB of RAM. You can also install multiple machines for your hosting server instead of having a single hosting server on a single machine. For the spatiotemporal data store, again, it's 32 GB of RAM on each machine. And for GeoAnalytics Server, it's 32 GB of RAM for each machine. And as I mentioned earlier, it's recommended that you have GeoAnalytics and spatiotemporal store one-to-one relationship, meaning if you have 3 machines for the GeoAnalytics server, you should also have at least 3 spatiotemporal data store machines. That brings us to the conclusion of this presentation. So we want to highlight a few things. So GeoAnalytics Server is available out of the box, and you can easily install with your ArcGIS Enterprise. And GeoAnalytics Server provides the distributed analytical capability that previously was not available. And this helps you process your big data faster. And GeoAnalytics Server makes processing of big data easier and sharing with your organization.
In the case where you have Portal on the other end, that's your entry point where you're doing the actual input, is there any processing that's happening on the local machine?
On Portal?
Yeah.
No. No.
So the basic Windows.
Yep, you're fine.
And GeoAnalytics Server provides an analysis, space and time analysis capability for your server. And then finally, it lets you see the big picture in a clearer and more meaningful way. And that brings us to the conclusion.
So I didn't actually show you the result in the Jupyter Notebook. So I'm going to quickly show you that it actually ran and what we can do quickly, very quickly. So let me duplicate. So I just ran this one when we last left off, so run hotspot analysis on that layer. I have a result. I have a quick warning message, so it's going to return your warning and error messages. Something that we added to GeoAnalytics in 10.5.1 is that if you don't set a projected coordinate system, but the analysis requires it, we default to 1. So we just default to world cylindrical equal area for binning because we know that's a safe default, but I definitely always recommend to set your projection. So we've created the result. I just do process map, so GIS map, and I just know that I'm in Houston, so I create an empty map of Houston, and then all I do is I add my layer. So there's the layer I've just created. This layer is available in Portal, so I could go open it up in Pro right now if I wanted to. I could open it up in Portal and continue analysis there, or I could keep using the notebook. And then other than that, please fill out the survey. I'm sure you've seen the slide on how to do it, but I think Ravi can provide it.
There you go.
And then we're open for questions. Yes.
Back to the sample, let's just say the reconstruct tracks from like the hurricane data. That the result, the tracks are actually stored as content as a layer.
Yep.
Portal.
Yep. So that's a feature layer in your portal.
Okay. So I would assume that if that was a job or something that we wanted to repeat, you could script that.
Yep. So I didn't repeat the question. The question was the layer created from reconstruct tracks, is that something in Portal? And then can we script it? And yes, so you could do something with the Python API. You don't need to do the Python API in the Jupyter Notebooks. I find them really great for demoing and prototyping, but then I just go and create a Python script that I can run all the time. And if you're already using REST, so if you're scripting through REST already, you can do REST as well, because there are REST endpoints for each tool.
Thank you.
Any other questions? Well, feel free to come up and ask us questions. We're still here, I think, for a while. We were very quick. And then we're also available at the islands downstairs. So if you haven't been to the showcase, I think it's the best part of the UC, so definitely go talk to product engineers, developers working on the products, not just for GeoAnalytics, for anything else. We are at the big data tower in the spatial analytics area, but you'll find lots of people down there as well if you have other questions. Thank you.
Thank you.